All right, so this is the Unit 3 test. So for the first one here, we've got a polynomial. And first thing we got to do is it says to write the polynomial in standard form. So remember standard form, we want to look at the exponents. So we're going to look at all the exponents, and we're going to go highest exponent to lowest exponent. Remember, if we have a number, that counts as x to the 0 power, so it's always going to go at the end. So the 11 is always going to go at the end. So standard form, we get 18 x to the 7th, because 7 is the biggest exponent. And then the 6x to the 5th comes next, because that's the next highest exponent. And then since we have 11 as our pure number, or 11x to the 0, 11 is going to come last. For part B, it asks for the leading coefficient. Since I'm in standard form, I can just read the first number. It's 18. You could come up here and look at the highest exponent, and then you want that coefficient. For the degree is going to be the highest exponent that we have, so that's 7. Again, I can look over here if I want to look for the highest exponent, but it's always going to be the first term if it's in standard form already. And lastly, for the type, we want to count the number of terms. In this case, we've got 1, 2, 3 terms. So for 3 terms, this is a trinomial. So that's what we got for all of those ones. All right, number 2. This is kind of a long one. Here we've got to graph the function f. For our function f of x equals x cubed plus 0.5x squared minus x plus 0.5. So I think what we got to do is just graph it. So I'm going to go ahead and actually graph it out in Desmos. We'll see what we got. Oops, I kind of forgot what it was. I know we have an x to the 3rd minus 0.5x squared. I think it was plus x minus x, and then plus 0.5. All right, so that's what we got. Kind of an interesting looking graph. Everything looks like it's okay. It doesn't look like there's any hidden zeros. So kind of the 2 key points, we don't have too many key points, but the 2 key points are negative 0.3760 and 0, 1/2. So let's go ahead and we'll plop those on. So we've got one point that's kind of like here, and then another point that's kind of here. And we can tell at the end behavior, we should be going up, and then we should be going down. So that's our graph. So we've graphed the function f. Next part says identify all turning points. We have to see where we're going from increasing to decreasing, or we have any maximum or minima, but I don't see any turning points on this one. I think this one just doesn't have any turning points. So in this case, a little bit weird, but there's no turning points. So remember, our turning points would typically come a little bit thinner. Our turning points would typically come where we've got maxima and minima, but there aren't any of those over here, so it's kind of strange. Next, we have identify all x-intercepts. So the x-intercept is going to be right here. So that was 0, comma, and we just have to remind ourselves what it was. Negative 3.76, so not 0, comma. So negative 0.376, comma 0. So it's just always going to change. All right, and then for the y-intercept, our y-intercept was right here. That was just at 0.5, so 0, comma 0.5. And then the next thing we want to do is identify wherever we are positive. So remember, positive means we have to be above the x-axis. So in this case, we're starting to get above the x-axis right here. So we start to get above the x-axis from negative 0.376 until we go all the way out to infinity. Identify where we are negative. Well, we're negative on the opposite side. So we're negative all the way down here. So that means we're negative from negative infinity until negative 0.376. All right, list any intervals where the function is increasing. And this is kind of interesting because for this one, it turns out that we're actually increasing throughout the whole graph. There's no turning points, and we know we're going up at the end, so we're always increasing. So it's a little bit strange, but negative infinity to infinity is going to be where we're increasing. And then list where we're decreasing. Well, we're not decreasing anywhere. It's always going up and to the right. There's no point where it goes down and to the right. So kind of a weird graph, but that's what we want to do for this one. All right. Number 3, we want to add these. So if we want to add them up, that means we want to combine like terms. So I've got negative 6x to the third, and x to the third is negative 5x to the third. Next, I look for my x squareds. Negative 4x squared minus 1 more x squared, or plus negative 1x squared, is going to be minus 5x squared. I should have x's next. I don't see any x's. Probably should have been a typo there, but we'll just consider it to be no x's. We'll do it as is. Our pure number, we've got negative 8, negative 9, and 4. So that's negative 17 plus 4 is negative 13. And that's our answer. So we've combined all of our like terms. We've added them up. So that's what we wanted to do. For number 4, we need to multiply. So to do this, what we want to do is multiply m by this entire expression. So m times m squared minus 2mn plus 2n squared. And then we also have n plus n times m squared minus 2mn plus 2n. And then we're going to distribute. So it's a double distributive question. So we'll take the m and we'll multiply it by everything. So m times m squared is m to the third. 2mn times m is 2m squared n. M times 2n squared is 2mn squared. Then in green, we've got n times m squared. Again, I'm going to put it in alphabetical order. It just makes a little bit more sense to do it that way. So m squared n. N times negative 2mn is negative 2mn squared. And then n times 2n is 2n, oh, this should be 2n squared, is 2n to the third power. So that's 2n squared right there. All right. Pretty good. So now we see if there's any like terms to combine. M to the third is all by itself. That's the only thing that has m to the third, so that's pretty easy. This one has m squared. This one has m squared, and they're both m squared n's. So minus 2 of those plus 1 of those is minus 1 of those. So minus m squared n. 2mn squared minus 2mn squared. Well, that looks like it actually cancels out. So that's going to become 0. Those ones actually go away. That becomes 0 when we combine those. And then at the end, we've got 2n to the third. So we don't always cancel out. This time it ended up that we canceled them out, but that's how it works sometimes. Cool. All right, so that's number 4. This is the final answer. All right. For number 5, is x plus 5 a factor of p of x equals x to the third plus 4x squared plus 2x plus 35? If so, write p of x as a product of 2 factors. If not, prove why. All right, so we got a couple options that we could do with this one. Probably most people are going to say, you know what, I kind of like the synthetic division. So let's do x plus 5 equals 0. Subtract 5 to find out what x is. X is negative 5, so negative 5 is going to go in our box. From the equation, I've got 1x to the third. I've got 4x squareds. I've got 2 x's. And then I've got 35 as my number. So what we do is we bring down the 1. That's standard. Negative 5 times 1 is negative 5. 4 times negative 5 is negative 4. 4 plus negative 5 is negative 1. Negative 5 times negative 1 is 7. I'm getting ahead of myself. It's just 5. 7's going to go below it. It's 5. Add them up, we get 7. Negative 5 times 7 is negative 35. Add them up, and we get 0. So to answer their question, is it a factor? The answer is yes. Okay, so we've answered the question. So the next thing we got to do then is write it as a product of 2 factors. So what we're going to do is take our result down here. And we have to remember, since we started with x to the third, when we divide it by 1x, we're going to be left with x squared at the beginning. So x squared minus x, or minus 1x, plus 7. And then we divided by our x plus 5 over here. So we have to write that as x plus 5. And that's our final answer. It's got all those parts to it. So there's a lot of parts to that question. So we had to answer it, yes or no first. That's the first thing we had to do. Then the next thing we had to do is we had to actually do the division, which got us 0. That gave us the x plus 5 in black. That's what we divided by. And lastly, our result, quotient was 1, negative 1, and 7. So that gave us the x squared minus x plus 7. So that's how to do that one. Again, that's the route that most people are going to take. There is another way to do it. If you wanted to use your long division, you could use your long division. So if you did want to go through it with the long division, we do have x plus 5. We do have x to the third plus 4x squared plus 2x plus 35. And what we do is we can run through our long division. So we know x squared times x would be x to the third. So that's going to give me x to the third. X squared times 5 is 5x squared. Gotta switch the signs because we're subtracting when we do long division. We get minus x. Bring everything down. Plus 2x plus 35. All right, now we see, all right, I got x. I need to get to negative x. So that means I'm going to do minus 1x. So x times x, this should be x squared. X times x is x squared. Sorry, x times negative x is negative x squared. Negative x times 5 is negative 5x. Switch all the signs up because we have to subtract. So we're going to get 7x plus 35 when we bring the 35 down. All right, and then we got 7. So if I multiply this x by 7, I'll get 7x. So plus 7. 7 times x is 7x. 7 times 5 is 35. Subtract them, so that means we got to switch the signs. And we end up with 0. So there's no remainder. So we don't need to write anything over here because there's no remainder. And since we got to 0, again, the 0 is the key that says, yes, it does work. Writing it as a product of two factors actually might be a little bit easier here because we already have what we had in green. It's just up at the top. It's staring us in the face. So we don't really need to do any other tricks. We just get x squared minus x plus 7. And we started with x plus 5 over here. So we could do that too. And that's kind of the two ways to do it. Now, if you want, you could use the graph to check if x plus 5 was a factor, but then you're kind of stuck. You have to kind of figure out what the other polynomial would be. So you may as well not do it with a graph on this one because it won't get you to the end. All right. So back here, so we got this polynomial function. So first we have to sketch the graph. So first thing we want to do when we want to sketch the graph is probably just graph it. So I just graph it in Desmos. So I can bring it up here in Desmos. So there I've made my graph. We can see I typed it in. I got most of my key points. There's still a couple more key points over here. So when we want to make a sketch, we definitely want to have all of the zeros in. So 0, 0, and 1.80, 0. And this time the y-intercept's also a 0. So that does kind of save us at least 1 point. But we'll put that in. So we got 0, 0, and 1.080. Next thing I want to do is get all the turning points. And it's kind of cool. This one does have some turning points, unlike that other one that we looked at. Oops, wrong button. So our turning point here, we can see we've got two maxima. We got a minimum down here. But we need to put our turning points in. So we've got negative 2.529, negative 0.305. So that's like negative 2.5. And we don't quite get 1, 2.5. Don't quite get back to the line. That's okay. That is our maximum too. So that's the highest it gets. Locally over here, and our local maximum over here is at 0.629, 2.855. So 0.62 and then 2.9. Oh, so right about there. Now we also need the minimum. So let's grab our minimum. Our minimum down here is negative 1.1, negative 5.05. So negative 1.1, 5.05, a little bit past negative 5. Our end behavior that we've got is both times we're going down. So we know we're going down on both sides. And we just kind of complete the rest of the graph. So we went down to here, up to here, and then back down. And that's a decent sketch. So that's a decent sketch of what's going on. So what we need to do is we need to match up each of our pieces. So first one we got is we've got the intervals from negative infinity to 0, and then 1.08 to infinity. Well, that would be this part of the curve and this part of the curve. And if we look at those two parts, there we're actually below the x-axis. If we're below the x-axis, that means that we're negative. So we'll put a little star on that one. Next part we want to look at, we want to go negative infinity to negative 2.529. So that's this part of the graph. And then negative 1.1 to 0.629. So that would be from here to here. So if we look at the blue parts are where we're going up and to the right. So if we're going up and to the right, those are the parts where we're increasing. So I'll do the circle for that one. So that one's going to be the circle. Next part we want to go negative 2.529 to negative 1.1. So that's this. And then 0.629 to infinity. So that's actually the complement. That's everything that's not increasing, which would mean we're going to be decreasing down and to the right. So that one gets the square. Process of elimination, the last one's got to be the triangle. 0 to 1.08. And yeah, so just that part up there is the part that's above the x-axis. So that's going to be where we're positive. So that's what we got. So pretty cool. A little bit of vocab check. We did pretty well with that on the quiz. So hopefully this will go well again on the test. Number 7, we got the box again. So Teo's constructing another box. This time it's 10 inches wide, 15 inches long. I don't know why it says J here, but Teo. Cut squares of equal size from each corner of the cardboard and then folds up the sides of the box. Write the following function v for the volume in terms of x in factored form. So we know that volume is length times width times height. So in factored form, our length is going to be 15, but we have to subtract away these two x's. So 15 minus 2x. Our width is going to be 10, but again, we have to subtract away these two x's. So 10 minus 2x. And then the height is just going to be x, because when we folded it up, this little cutout piece ends up being the height. So times x. Part B says we have to do it now in standard form. Not too bad. We're going to just double distribute from what we've got. I'm going to save the x for the end. So v equals 15 times 10 minus 2x minus 2x times 10 minus 2x. And again, this is all just times x. So that x just hangs out. We're not going to deal with that yet because we can only do two things at a time. So 15 times 10, 15 times negative 2, 150 minus 30x. Negative 2 times 10, negative 2 times negative 2x. So we got negative 20x plus 4x squared. All right, we still got that x hanging out at the end. So now what we need to do is we could combine like terms, or we could just distribute the x in right now. Personally, I like to just distribute it right now. I think it makes it a little bit easier, but if you wanted to combine like terms, you can definitely flip this step in the next step. So 150x minus 30x squared minus 20x squared plus 4x to the third. And the reason I like doing it a little bit better this way is since it has to be in standard form, I'm going to kind of do my standard form right now. I'm going to get all my x cubed to go out front. So I'm going to go 4x cubed. I'm going to combine my like terms that I have. I've only got these ones as like terms, but that's minus 50x squared. And then at the end, I still got the 150x, so plus 150x. So again, I like doing that at the end only because it kind of combines the like terms and puts it in standard form at the same time. But that's it. So that's what we got for that one. Another repeat. 8, use polynomial identities to factor 64x to the cube minus 1. So again, we can tell that we definitely have a difference because we have a minus sign. And I've got x to the third, and that's a pretty good indication that we're going to do it of cubes. So we just need to use the difference of cubes formula. So difference of cubes formula is the one that is a minus b times a squared plus ab plus b squared. Now when we figure out what a and b are, since we're doing difference of cubes, we're going to cube root these ones. So we're going to get 4 is the cube root of 64. X is the cube root of x to the third. And 1 is actually the cube root of 1. So that just stays as 1. So that means we're going to get 4x minus 1, 4x quantity squared, plus 4x times 1, plus 1 squared. We want to resolve our squareds that we have here. So 4x minus 1. 4 times 4 is 16x squared. 4 times 1 is 4x. And 1 squared is 1. And that's our answer. So again, we're breaking it up. We go from a subtraction to a multiplication. So that's the idea behind that. All right, for number 9, we have the binomial theorem. So we have to expand g minus 3h to the 4th power. All right, well, so this one we need the triangle. So we need Pascal's triangle. So we start with 1 at the top, 1's on the side, and 1 plus 1 is 2. 1's on the side, 1's on the sides, 1 plus 2 is 3, 2 plus 1 is 3. I see my exponent's 4, this is only 3, so I gotta go one more row. So 1's on the side, 1 plus 3 is 4, 1 plus 3 is 4, 3 plus 3 is 6. So I got all my coefficients for Pascal's triangle. So to do this, I know that my first term is going to be 1. I know in place of the x is the g, so I'm going to do g to the 4th power, because remember we always start with whatever our exponent is up here. First one's done. All right, next number I got is 4. The g's or the x's have to go down by 1, so g to the 3rd power. And my y or my b is going to be negative 3h, so minus 3h to the 1st power. So now we're starting to get these negative 3h's to show up. All right, next one we got is 6, because 6 is our number over here. Counting the g's down, so g goes from 3 to 2. Negative 3h's count up from 1 to 2. Now I got a 4. G's are counting down, g's go to g to the 1st. H's are counting up, or sorry, the negative 3h's are counting up, so negative 3h to the 3rd. And then at the end, I got a 1. It's my 1 from the triangle. I'm out of g's, so I don't need to write g anymore. But I have negative 3h to the 4th power. All right, so then what we want to do is we want to try and simplify it if we can. We could do a little simplifying. G to the 4th will just stay as g to the 4th. The one, I mean, we could write it if we want. 4 times negative 3 to the 1st is minus 12. G to the 3rd, h to the 1st. I don't need to write the 1st also. Next one, I got 6 times negative 3 squared. Well, negative 3 times negative 3 is 9. 9 times 6 is 54. G squared, h squared. All right, next one I got. 4 times negative 3 to the 3rd. So negative 3 to the 3rd is negative 27. So that's going to be negative 108. G to the 1st, I don't need to write the little 1. H to the 3rd. And then bringing up the rear, we've got negative 3 to the 4th times 1. So negative 3 times negative 3 is 9. Times negative 3 is negative 27. Times negative 3 again is going to get us 81. And that's it. So that's what we got. I think we did one that was like this in class, because I kind of remember the 108, but that's what we want to do. So it's going to be one of the Pascal triangle questions. Number 10, volume of a cube with side length x is given by volume of x is x to the 3rd. Volume of a sphere with radius half x is shown in the graph. When x equals 2, which volume is greater? Circle your choice. So we know that the sphere is the line right here. So let's label this one as sphere. So I can look that up. It's right there. So that's our volume of the sphere. So I really need to figure it out for the cube. Cube is going to be x to the 3rd. Well, if x is 2, the cube is going to be x to the third, which is 2 to the third. 2 times 2 is 4 times 2 is 8. So we get 8. If I graph 8, 6, 7, 8, this is the cube. And at 2, we can see the cube is higher, so the cube is going to be greater. So that works out. So there we go. Nice. All right. Next up, we got number 11, use synthetic division. So here I'm telling you, you got to use the synthetic division. So that means you're going to score it if you actually use the synthetic division. Divide x to the fourth minus 5x cubed plus 2x squared plus 6x plus 6 by x minus 2. So here again, we see we got the x minus 2. So what we want to do is we want to make x minus 2 equals 0. Add 2 to both sides to get x equals 2 in the window. All right, our numbers that we got 1x to the fourth minus 5. That's a little bit too close. Negative 5x to the third, 2x squared, 6x, and 6. So this was pretty good. No zeros to throw us off. 4, 3, 2, 1. We're all in business. I didn't need to put any zeros into the question. All right, let's divide synthetically. Drop the 1 down. 2 times 1 is 2. Add them up. Negative 3. 2 times negative 3 is negative 6. Add them up. We get negative 4. 2 times negative 4 is negative 8. Add them up. We get negative 2. 2 times negative 2 is negative 4. Add them up. We get 2. All right, that's fine. We don't have to get 0 every time. Remember, we only get 0 if it works out. It doesn't work out this way. So in order to finish off our division, we just have to write down our answer. And our answer is we started with x to the fourth. So this one's going to be x to the third. So 1x to the third. Then we just go down. Minus 3x squareds, minus 4x's, minus 2 with 0x. And then here we got the remainder is 2. So plus 2. And now the x is going to go on the bottom with x minus 2. X minus 2. And there we go. Remember, that's like an x to the negative 1 because it's hiding down there in the denominator. So it does make sense. It goes in order. That's it. That's it with 11. For 12, we've got a function here. We have to find the zeros of f of x and sketch the graph of f of x. So again, we could graph it if we wanted to. In this case, though, it tells us to find the zeros. So let's find the zeros real quick because we could rewrite this. We can see that we could divide them all by x, which is kind of interesting. X squared plus x minus 2. And then, well, wait a second. We just have a quadratic here. So if I really want, I can find things that multiply to negative 2 and add to 1, which is going to be 2 times negative 1. 2 plus negative 1 is 1. So it turns out f of x is really x plus 2, x minus 1. We could break it apart. We could factor it. And that gives us all the zeros. This is going to give us x equals 0. Here, this is going to be x plus 2 equals 0, minus 2 both sides. X equals negative 2. X minus 1 equals 0. Add 1 both sides. We get x equals 1. So it turns out we didn't even need the calculator. We just can go ahead and plot these zeros right now. X equals 0. X equals negative 2. X equals 1. Sketch the graph of f of x. All right, well, again, here a graph might help us out, but we could also just look at it. Here I've got x to the third. That's a positive leading coefficient and an odd exponent. So this 3 up here is odd, and then x cubed itself is positive. So positive odd, I actually know what that looks like, because positive odd means I'm going to go up and to the right, down and to the left. And these are the only places where we cross. We can see that we only hit them each one time, so the multiplicity is 1 on all of them. So we just have to cross through all of them, and then we're all set. That's it. My sketch is done. Now my heights might be totally wrong. That's fine. My purple arrows, they might be a little bit too shallow or a little bit too steep. That's fine. We just have to sketch it. That's it. That's all we got to go for. So we're done with number 12. We can do without the calculator. For 13, find the zeros of the function f of x equals x cubed minus 7x squared plus 11x minus 5, and describe the behavior of the graph as either crossing or touching at each zero. All right, well, here I think we probably want to graph it. So I'm looking at that one, and I'm seeing, I don't really see too much that I really can factor out of that. Because if I try do some factor by grouping, it's not going to work. So I think we just have to go ahead and graph it. So let's just throw it into the graph and let's see what we get. X cubed minus 7x. I'm going to be surprised, I think, by this one. Okay, so far so good. Plus 11x minus 5. Okay, interesting. Very interesting here. Is that what we want? Is it starts with an x cubed? It does start with an x cubed. Looks like it worked out. Very strange. I guess this one we could have factored. Yeah, I'm not seeing a good way to do it with factor by grouping, but it does work out if you do want to factor it. But here's what we got. We've got it hitting at 1, 0. So it's going to bounce. It's going to hit at 1. And it's, I guess this is going to call as touch. Let's call that touch instead of bounce. That's the words that they use. So we just touch, and then we kind of go down. And then over here at 5, we cross. Okay. Is that it? I think that's it. We should have 3 answers, though, so let's double check here. So we got 1, and then remember when we bounce, when we touch, that counts as an even number, so that's got to be at least 2. So 1 plus 2 is 3. So yeah, that's it. So that's all we got. So that's it with this one. Huh, that one ended up being kind of easy. All right, sounds good. 14, what's the remainder when f of x equals x to the 4th minus 8x squared plus 10x plus 22 is divided by x plus 3? Again, you've got your choice of either synthetic division or long division. If you do the synthetic, again, we need to remember to switch this into x equals negative 3. And then when we use our little window, we got negative 3 in the window. We got 1x to the 4th, and now we need to watch out because now there's no x cubes, so we do end up with a 0 in this one. Negative 8x squared, that's normal. 10x, and then 22. So again, 1x to the 4, no x cubes, negative 8x squared, 10x, and then 22. Usual moves here. We'll go ahead, we'll drag the 1 down. Negative 3 times 1 is negative 3. Add them up, negative 3. Negative 3 times negative 3 is 9. Add them up, we get 1. Negative 3 times 1 is negative 3. Add them up, we get 7. Negative 3 times 7 is negative 21. Add them up, we get 1. Okay, well, I guess 1 is our remainder. That is the answer. That's kind of weird. Usually we can get some big numbers when we have to find a remainder, but I guess this one we kept it small. If you want to do the long division, you are allowed to do long division. X plus 3. X to the 4th plus no x cubes minus 8x squared plus 10x plus 22. We think, all right, to get to x to the 4th, I have to multiply by x to the 3rd. So x to the 3rd times x is x to the 4th. X to the 3rd times 3 is 3x to the 3rd. We want to subtract them, so we switch the signs. So we get negative 3x to the 3rd. I'm going to be lazy and only drag down 1. So now I need to do x into 3x to the 3rd. So I need to multiply by negative 3x squared. Negative 3x squared times x is negative 3x to the 3rd minus 3x squared. I want to add them, or I want to subtract them, so I switch the signs. So that gives me, oh, that's not 3, that should be a 9. we go. So that's going to give me 0, and then that's going to be 1x squared. All right, I'm going to be lazy again and just bring down 1. Okay, so here this doesn't seem too bad because I need to get to 1x squared. So x times x would be 1x squared. So x squared. X times 3 is 3x. But again, we got to swap the signs because we have to subtract. So we go to 7x. I'll bring down the last one. Plus 22. For the last one, I got x. I got 7x, so I need 7. So 7 times that would be 7x. 7 times 3 is 21. I have to subtract them, so I have to switch the signs. And that's going to get me at 1 again. So I could get 1 that way too. That worked out. All right, nice. If I really wanted to, I could even go a little bit fancier. I could actually plug in -3. So remember we said we were also allowed to plug in things using our remainder theorem. So if I really wanted to, I could find -3 to the 4th power minus 8 times -3 squared plus 10 times -3 plus 22. I'm allowed to do this as well. This is going to be, not that giant line that looks like that. This is going to be 81 minus, that's 9 times 8 is 72. So I know that that's 9. Minus, because that's a negative, so 30 plus 22. So -30 plus 22 is -8. So 9 minus 8 is 1. That worked out too. So I could do it that way. I could even graph it if I want and find out what happens at x equals 3, because that's the same thing as plugging it in. So that way works too. There's a lot of ways to do this one. I like this one. It's a fun one. Anyway, that's 14. 15 lists all the possible rational solutions. So we don't need to solve anything. We just need the possible ones. So this is where we've got our p's and our q's. So remember, p is always going to be our number on the end. Ignore the equals 0. So since p equals -1, the factors of p are just going to be 1 and -1. So plus and minus 1. Then we got to get q. Q is our number out front. Q is the leading coefficient. That's a 3. So we need the factors of Q, which are going to be plus or minus 1, plus or minus 3, because 1 times 3 would be 3. And then our answer is going to be that giant list. So we have to do all the P's divided by the Q's. So our list of P's divided by Q's are going to be plus or minus 1 over 1. We only need to write the plus or minus once. We don't need to write the plus or minus twice. And plus or minus 1 over 3. So our giant list is actually just 2 things. Well, that's okay. That's fine. We can have a short question. But again, we're taking all of our P's and dividing by all of the Q's. So I did this one divided by that one, and then this one divided by the 3. If there were more P's, like let's say there were a 5 here, I'd have these and then also 5 over 1 and 5 over 3. I would keep going until my whole list is done. But that's it. For 16, find all the real and complex solutions of x to the third minus x squared minus 20x plus 25 equals -25. So before I do anything, I realize since I want to find solutions, I have to make sure that this is 0 on this side. So I'm going to add 25 to both sides, because if this side isn't 0, I actually can't do much. So I get x cubed minus x squared minus 20x plus 50 equals 0. All right, now from here, I got some choices. I'm thinking that instead of finding all the possible solutions and doing guess and check, I think I'm going to go to my graph. I think the graph's going to help me out to do some guess and check work. So x to the third minus x squared. So x to the third minus x squared, I believe it was plus 20x and plus 50. Is that it? Let's see. Minus 20x. Okay, that looks pretty nice. I see a 0 popped out. So again, that looks kind of like a garbage graph, but if we zoom out, I'm sure we'll see something a little bit nicer. Oh, okay, there's the rest of the graph. Yeah, it looks like it only has 1 0. It only looks like the 1 0 is at -5. So I'm going to write that one down. We definitely want x equals -5. That seems solid. That came from the graph. And that's actually going to be all the real ones. So what we have to do now is find the complex ones. And to get the complex ones, what we need to do is some more division. I'm going to choose synthetic division. I think it's going to be a little bit nicer for this. And I have to remember I'm using this equation. I'm not using the original equation since I moved that 25 over. So I've got 1x to the third. I've got -1x squared. I've got -20x. And I've got 50. Now, we know it should work out because the graph told us it's going to work out. So if it doesn't work out, then I probably did something wrong with the synthetic division because we know that this should work out. So let's hope that we did it right. So 1 times -5 is -5. Add them up, -6. -5 times -6 is 30. Add them up, we get 10. -5 times 10 is -50. Add them up, we get 0. So perfect. We knew it was going to work out. And the reason we do this is now we have this quadratic. So we started with x to the third, so we get x squared minus 6x plus 10 equals 0. Now, we know this isn't going to factor nicely because if it did factor nicely, it would show up on the graph. It didn't show up on the graph. So that means what we got to do here is we got to use the quadratic formula or complete the square, but most of you are not going to pick completing the square. Well, you could on this one. This one's a pretty good one to complete the square with. But quadratic formula is -b plus or minus square root of b squared minus 4ac all over 2a. Remember, this is going to give us our x values. We aren't done with this. So that means we're going to get -6, because this is b, plus or minus the square root of -6 squared, still b, minus 4 is just a 4. A in this case, a is 1 because we just have 1x squared. May as well fill in the other a on the bottom while we're here. And then c is going to end up being the 10. So c is 10. All right, so we do like we did in the other unit. We start to simplify things. So 6 plus or minus the square root of 36 minus 4 times 1 times 10 is 40. 2 times 1 is 2. So that's going to give us 6 plus or minus the square root of -4 over 2. All right, and so yell at me. We'll pause right here, and we'll pick it back up. All right, immediately picking it back up. So the thing here is we've got this -4, square root of -4, and to solve that, we actually have to go back and we have to break it down like we did the breakdowns. So square root of -4, it's negative, so I have to get that negative out of there. And the square root of -1, we know that, that's I. Square root of 4, we actually know that, that's 2. So this ends up being 6 plus or minus 2i over 2. Now, since I can divide both of these by 2, we could actually simplify it down to 3 plus or minus I if we want. But we have to be careful. That's not the only answer because we had x equals -5 also. So our final answer is going to be 3 plus or minus I and -5. And that's all the answers. Now, is that all the answers? Well, let's think. We should get 3 answers because we have x to the third. We've got 1 from the -5, 1 from 3 plus I, and 1 from 3 minus I. So you do have all 3 answers there. So since we got all 3 answers, pretty happy, we can move on. 17 cubic polynomial has 2 irrational zeros, -b and square root of b and negative square root of b, where b is a rational number. Describe the coefficients of f. So the idea here is that since these are our 2 irrational zeros, that means that the answers had to be x equals square root of b, x equals negative square root of b. Moving them over, x minus square root of b equals 0, x plus square root of b equals 0. And then if we multiply those together, x x minus square root of b times x plus square root of b, it's a b, not a 6, would be x times x is going to be double distributive property. So x times x plus square root of b is x squared plus x radical b. Probably should put the radical b first, but I don't want to put the radical first. Square root of b, so minus radical b, x plus square root of b, quick distribute, minus x square root of b, negative square root of b times positive square root of b is negative square root of b squared. Simplifying things, those cancel out. Those are the same. So we just have x squared. Square root and squared canceled out. So we just have minus b. And it turns out we get just a x squared out front. So it's asking for the coefficients, and it's just a 1 and a b. It tells us that b is a rational number. So it turns out we've got only rational numbers. And that was one of our theorems. So I just kind of proved it out again. But the idea is that if we have that, it's always rational numbers. So if you see that, you should probably pick that they're all rational numbers. Whether it's these square roots or whether it's the imaginaries, because again, if we go back one, this one kind of is the one with the imaginary numbers, and we saw that all of our coefficients here, 1, negative 20, and 50, those were also all rational. So I would recommend picking all rational numbers. For 18, how does the graph of 2x cubed minus 1 differ from the parent function? We could graph it, but that seems like a hassle because we can see right here, we have a 2 out front, which means we have a vertical stretch of 2. And we have minus 1 at the end, so the minus 1's not in parentheses, so that means we're going down 1. And that's it. That's the entire question. Just remember, if it's like negative x to the third, this would be a reflection. So vertical reflection. And if we had something like x plus 7 to the third power, here we would be going to the left 3. And that's kind of the only other two options we could have would be a left-right movement or that vertical reflection. So that's it with 18. You can graph it. You're going to get the down 1 pretty well, but the vertical stretch of 2 might be a little bit tricky. So it's a little bit easier to see that with just the number out front. And I think this is it, right? Number 19? Yeah. Is this function odd, even, or neither? So a couple ways to do it. With 11, we want to remember that 11 is the same thing as x to the 0 power. So we could remember that because we had to do that in standard form anyway. It always counted as 0. And if we notice, all of those are even. So that's actually our quick rule for even. If all of the exponents are even, it's automatically even. So we can be done right there. That's not true if they're all odd, but it is true if they're all even. Because sometimes with the odd, you get a little bit confused with the coefficient. If we want to graph it, that would be the other way to double check. One of the other ways to double check it. So let's go ahead and graph it real quick. Oops, I kind of forgot what it was. 23x to the 6th. Plus 5x squared. And it's 11. Let's go home to see it a little bit better. And we still got to zoom out. So this thing, it is symmetric. So that's kind of our visual clue, is if it's symmetric about the y-axis, which it is. So the left side of the y-axis and the right side of the y-axis look the same. We can see that this is the exact same point, positive and negative. So that's another way to do it. So we could tell it's even because of that. An odd function would be the 180-degree rotation. So that's how you can figure that out with the graph. The other thing we can do is we can actually find f of negative x. So this is kind of the fancy way to do it, by plugging in a negative x wherever we see x. So that would be 23 negative x to the 6th plus 5 negative x squared minus 11. And if we simplify this, Negative to the sixth power is -1 times -1 times -1 times -1 times -1 times -1. So 6 negative ones would make it back to positive. Negative x squared is negative times negative is back to positive. 11 doesn't change. And it turns out that this is the exact same function that we started with. So since this is the same function that we started with, we would also consider this even if we're in this case where f of negative x equals f of x. So that's another way that you could do it. You could do that algebraically. So that gives us even. If we wanted to get the odd versions, we would end up with f of negative x equals negative f of x. So we would end up with negatives. All the signs would be flipped. If it were odd. It's not odd. It's even. But if it were odd, this is what you would get if you did it algebraically. We talked about the 180-degree rotation. I would be a little bit hesitant with all the odd exponents, which you can do, but you just have to watch out because if there's a constant here, we have to remember that's x to the 0. 0 is not odd, so that constant would automatically make it not odd. Neither would be some sort of mix. So if you just didn't get one of these two special cases, it would be neither. And that's the entire thing. So there we go.